Hello and welcome. This is Mr. Meyer, and I'm here with a math puzzler to exercise your brain and make you smarter. This is what I call minnow mortality. Let's begin. Let's pretend I'm a wildlife biologist measuring the health of this lovely pond. The ecosystem includes fish as predators, minnows as prey, and algae as food. To estimate the fish population, I can just ask the fishermen what they're catching. To measure the algae, I can strain the water and measure the weight of the residue. But how can I estimate the population of minnows? Let's give it some thought. Why don't you pause the video and think about it. How do you measure something as elusive as the quantity of minnows underneath the surface of this lake? I hope you spent some time thinking about it. If you didn't, you're not exercising your brain enough. Well, a very normal, usual method of measuring population in the wild is called Mark and Recapture. So by setting out a trap, we collect a sample, put a mark on them. In the case of minnows, we might put a dot of paint on their tail. Then we release them into the wild population. So how does that help us measure the population? Well, we have to come back after the marked critters have mixed in with the wild population and then take another sample. So here's another chance for brain exercise. How can you use that second sample collected of both marked and unmarked animals to estimate the population? Give it some thought. Okay, as we set up our calculations, let's define some terms. So capital M is the total number of animals in the population. So these are the wild minnows swimming in the pond. N, small letter n, is the number of animals marked on the first visit. Large K is the number of animals captured on the second visit, of which small k are the number of captured animals that were marked. So we can make the assumption, since it's a closed system, that the percentage of marked animals in the pond is going to be the same as the number of marked animals in the sample. So the percentage of marked animals in the sample is small k over large K, and the percentage of marked animals in the pond is small n over large N. So what value are we looking for? We're looking for the total population, which is large, capital N. So do the arithmetic, pause the video, and solve for capital N. So it's fairly simple. Capital N is simply capital K divided by the Well, let me say that again. So capital N is equal to small n divided by the percentage of marked minnows in the second sample, which is small k over large K. Well, when you're dividing by a fraction, obviously it's inverted, and it looks as it shows there on the screen. So let's look at that in terms of our calculations on a spreadsheet. So on this spreadsheet shows rows and columns for the various samples. On day one, we captured 100 minnows, of which, of course, none had been previously marked, and we released them to the wild. So after they mixed, you can see that there were 100 minnows in the wild for this second sample. When we took the second sample of 100 minnows, there were 90 of them that were not marked and 10 of them that were marked. Okay, so the percentage of marked fish in the sample is 10%. Dividing the total number of marked by 10% gives us an estimate of 1,000 minnows in the wild. So, isn't it nice that we have, isn't it nice that the numbers come out even? Well, of course they do. This is fiction. Real life is rarely so tidy. So, we now have another 90 fish that we're going to release to the wild, so that on the third day, there's been a total of 190 minnows marked and released to the wild. So when we collect our sample of 100 minnows out of the minnow trap, and we observe 19 of them are marked, our percentage of marked fish in the sample is 19%, and so 190 minnows in the marked divided by 19% is, of course, 1,000. Again, we have confirmed with a second sample that our wild minnow population is 1,000. Okay, this is good. We've made great progress, but my ultimate goal has been to investigate minnow mortality. Remember the title of the puzzle? Winters at this pond are very dark and cold. With the pond iced over, weather is extreme. So with predators eating these minnows, my question is, how many of these minnows are going to survive until spring? So let's come back in the spring and find out. So after a long, hard winter, I come back in year 2, and on the first day I collect a sample of 100 fish, 100 minnows, and I find that 15 of them are marked. Well, if I assumed that I had 271 marked minnows in the pond, then if I divide that by 15%, I would get a large number. But wait a minute. It's been many months since I released those minnows. I've got no confidence whatsoever that I still have 271 in the pond. So I cannot rely on that. Instead, what I have to do is take my 100 minnows that I've captured and mark them with a different color of paint and release them into the wild so that I can measure, once again, the population of minnows in the pond. Well, my second sample, on day 2 in the springtime, I take a sample of 100 minnows, and I find that 8 of them have been marked with the new paint color from this spring. So the 100 minnows with the new mark in the wild divided by the 8% in my sample gives me a total population of 1,250. Oh, this is good. This is healthy. It looks like the minnow population is increasing. Okay, so I come back on the third day, and this time I find 14% of the minnows are marked with the new spring mark. Out of the 192 that have been released, gives me a confirmation that yes, there's about a 25 to 28% increase in the number of minnows in the pond. That shows a nice healthy number. So now the question for the students is, given the number of fish that have been marked from last fall, how can you calculate the actual number that is living in the pond? Well, I'm showing you the answers here. These are the numbers that I calculate. It shows that there has been a significant mortality in the fish in the pond. Instead of the 271 that I released last year, I've got maybe a little more, just about half of them still alive in the pond. So that's interesting to know. Now, I'm not showing you the equation to do that because I know that you are capable of figuring it out for yourself. So please write it down on paper, sign your name, be ready to talk about it in class tomorrow. Thank you very much. Hope you enjoyed this presentation. See you soon.